right, well, thank you. And as Nate mentioned, Thomas will be having conversations about some of his many projects that have interesting backstories, so looking forward to that. I'll try not to belabor things. But here's our lineup. I think this is a great assemblage of projects and people. So we've got the Chapel of St. Ignatius with Max Levy, Citizens Bank Center Tower, Joanna Hampton, the Dallas College Brookhaven Campus, Rob Barnes, the Urban Convention Center with Nagu Daly on their behalf, the Crow Museum at the UTD Athenaeum with Maria Gomez, the Dallas Police Memorial with Ed Baum and Joe McCall, and then the Art of Structural Engineering with Joe McCall. Now, just for the ground rules, each conversation will have approximately 8 minutes, so it's going to be a bit of a speed dating situation. But keeping in the celestial theme of the week, 8 minutes is about the time it does take for the sunlight to travel from the sun to the earth. So considering what a photon accomplishes in those 8 minutes, I have all the confidence that we can keep on track and stay on schedule. Thanks. So, just want to talk about Thomas here a bit. Now, I'm going to give a long list of accomplishments and a couple of personal notes, but I am truly deeply honored to introduce Thomas Taylor, whose illustrious career we celebrate today. Thomas Taylor, PE, has been a leader and innovator in the building industry throughout his career. He has practiced the art of structural engineering for over 60 years. Thomas joined Frank Chappell Associates after graduating from the UT School of Engineering and assumed the leadership of the company in 4 years. Taylor incorporated the company as Datum Engineers and helped to grow it into a nationally recognized firm. Thomas has now begun another exciting chapter in his career as principal and director of the Dallas office of DeSimone Consulting Engineering. A student of both art and architecture, Thomas has successfully practiced and focused on creatively applying structural engineering to support the artistic vision of architectural clients. He has been a project manager and principal in charge of over 50 structures in the Dallas Central Business District alone, and has been involved with numerous landmark projects, including the Nasher Sculpture Center, Thanksgiving Square Chapel, the Police Memorial of Dallas, the Perot Museum, the Federal Reserve Bank, the Dallas Convention Center, the AT&T Headquarters, stop me when you need to, the Citizens National Bank Tower, Brookhaven College, the Strutto House, the Urban Convention Center, page 2, and numerous national award-winning projects, including the St. Ignatius Chapel that we'll hear about, which is in Seattle. Currently, Thomas is involved with the Crow Museum at the UT Dallas Athenaeum and the Dallas Museum of Art, among other high-profile cultural projects. Over his career, Thomas has worked with such renowned architects as Renzo Piano, Steven Holl, Cesar Pelli, Philip Johnson, Antoine Predock, and Tom Main. Half of those are Pritzker Prize winners, plus other national and international design firms. His collaborations with local architects, including Bug Oglesby, E.G. Hamilton, Max Levy, and a few others that we'll hear about later, have been rewarding both professionally and collegially. Thomas was a pioneer in the development of several new structural systems, including the stack wall concept of precast parking structures, as well as the slender slip-formed concrete cores for bracing high-rise buildings, and a versatile reinforced brick cavity wall system. His concept of exposed arch pipe trusses suspending the roof of the expanded Dallas Convention Center created the largest column-free exhibit hall in the US at its time. Taylor is known in the industry and professional circles as a design-oriented innovator. In 1983, he was made an honorary member of the Dallas chapter of the American Institute of Architects. AIA Dallas also awarded Thomas with its Consultant Award, and the Texas Society of Architects elected him to honorary membership, quote, in recognition of his achievement in providing structural solutions that are practical and appropriate to architectural expression, unquote. He was honored with the Neiman Marcus Downtown Renaissance Award, and he was elected to the University of Texas Academy of Distinguished Alumni, Department of Civil, Architectural, Environmental Engineering. Thomas and his wife Dane have been active supporters of the UT School of Engineering and helped establish the Thomas Taylor Design Studio, a state-of-the-art design space for teaching the integration of architecture and engineering systems. Last fall, 11 of the jury's selections for the forum's 25 most significant North Texas design projects were those with Thomas and his team as structural engineers. Thomas has been active in civic affairs for many years. He served as vice president for programming for the Greater Dallas Planning Council and was on the advisory committee for Thanksgiving Square, the Cotton Bowl Foundation, and Preservation Dallas. Thomas also serves as an advisory board member of the Dallas Architecture Forum. If that wasn't enough, allow me just to share a few more points, personally speaking. So I've been lucky enough to find myself immersed in various architectural projects with Thomas. And it's only been maybe the last decade I've had the lucky fortune to actually have him as a collaborator and an advisor. Of the many oppositions that we struggle with in architecture, one of the most exhilarating to me is the delicate balance between the gravitational force and the aspiration for buildings to tread lightly. Now, architects, as they say, shape with light. And of course, structural engineers, well, they grapple with lightness. And this is where Thomas enters the scene. 13 years ago when I arrived here, I witnessed remarkable projects sprouting out all over the DFW Metroplex. And I really scanned the list of consultants. And there, like a recurring motif, was Thomas's name, gracing the most interesting teams. So I had to find out who Thomas Taylor was. And his reputation definitely preceded him, but we had not been using his services until fairly recently. But yes, what I would say is this process that might really escape notice. Thomas's creativity and ingenuity in the assembly and construction are his secret ingredients. It's that know-how. It's the ability to craft not only ideas, but actual, really decide how things go together. Concrete soars under his guidance, steel floats effortlessly, and he combines craft with purpose. That's going to be a constant theme I think you'll hear tonight. His methods of assembly are always unexpected and clever. Yes, they save time, they save material, and they often save money. But beyond that, they infuse delight, which is that intangible magic that elevates design. Thomas taught me that practical knowledge fuels purposeful invention. When a design threatened to turn generic, he would always nudge me forward to question the norms, and above all, to create exceptional designs. He doesn't let architects sort of just rest on their laurels. He's always one step ahead, sort of a chess match of sorts. And really, those lunchtime sketches with Thomas, those are probably my prized moments. It really was a fusion of ideas, whether it was in a sketchbook or on a napkin, and sometimes in that rare moment, a menu we have to sort of serve as our paper. So Thomas, I just want to extend my heartfelt gratitude.
Thank you.
Thank you for your unwavering support, your generosity with time, and for making our city a more captivating place. So I'm pleased now to introduce the guest of honor, Thomas Taylor. Give me a round of applause. Call first. Yes, come on up, Matt. Max.
Well, I'm surprised to say that I met Thomas 45 years ago. Can't believe this. I was a young cub at Bud Oglesby's office and had the good fortune to very early on sit in on some meetings with Thomas and Bud, and I learned firsthand how he can make a project sing. I was really spoiled early on. And I think it's just perfect that the St. Ignatius Chapel is one of the projects you want to talk about, because I think it's emblematic of your process. Thomas, you took the most utilitarian, mundane construction process, tilt wall construction. For the non-architects in the audience, it's what warehouses are built. And you brought to it an artistic dimension. How did you and Steven Holl arrive at tilt walls?
Well, it's always fun to be here with you, Max, and I still can't believe what Ron had to say, but in answer to your question, you introduced me to Steven Holl when we did the Stretto House, and you were his associate. And on the Stretto House, there were about 3 things that Steven really, really liked that I had done. And so when he got selected to do St. Ignatius Chapel, which was also his alma mater, he invited me to join him. And in his mind, he had this stone facade, this beautiful stone chapel that was going to be sitting there on the edge of the campus at the University of Seattle. And we just couldn't make it work. It's just a 4,000 square foot chapel, and the budget wasn't that tight, and wasn't that big in the first place. And it was so small that we just struggled and struggled and struggled, and we couldn't make that stone facade work and get it into the budget. And so then the idea of a tilt wall came up, and in those days, and that leads to one of the stories there, but in those days, the tilt wall industry was just strictly an industrial kind of construction, warehouses, industrial facilities. You didn't use tilt wall in beautiful architecture. So when the suggestion came up to Steven about, what do you think about using tilt wall? I was pleasantly surprised and quite surprised, and maybe would not have done what he did, but he said, well, fine, let's check it out and see how it works. So this little first slide that you see here, I took the architectural expression of the building and I marked all of the joints in the wall, that if we were going to do this out of tilt wall construction. I wanted to keep the weight of the precast concrete fairly light. I mean, typically we might use 125 or 150,000 pound panels, but on this campus site that takes such massive tilt wall construction equipment that I want to keep the equipment light and stay on the campus and kids still walk on and around us. And so one, I set a criteria of 65,000 pounds, and then I started marking these joints, and I started seeing the windows and the doors, and thought, well, you know, somehow or another there's got to be a relationship between the structural joints of the tilt wall and the windows and so forth. So I sketched this up, the one that you see here now, and then the next one is kind of another shot that shows all of the panels and all of the joints and the windows and the doors. And we brought it in the budget, and Steven really liked it, and I think the jointery helped him to like it, the way it worked around the windows and the doors, and it was actually a part of the architecture, not just some panel side by side. And so on the next one, then this is the tilt wall panel going up, and Steven actually stained the outside face of these panels, just like you might stain a concrete floor or something like that. That's not a colored concrete. That's a stained. I called Steven. I said, Steven, we got to tilt these panels up, and we got to put the big screw inserts into the outside face, so that's going to be visible. So from an architectural standpoint, what do you want me to do about all those screw holes in the panels? And he said, you just put them where you need them, and I'll take care of it. And I said, well, that's great. That's great. That's easy. But I was a little bit surprised. I figured that the architect would want to organize them and make them all look just exactly right or something. But so I talked to the tilt wall contractor, and we just put the joints where they were. I mean, put the inserts, because the big cables that they used to tilt that panel up had to have big screw inserts to connect to. And he created these little brass heads with a screw on them, and he screwed them into those screw heads, and you can see them on this picture. So where they are is where the contractor needed them, and that's the way he celebrated the construction, and that's the way he created the architecture. And in this same picture, you can see the jointery between two panels and the windows, and how the joints related to the architecture.
Y'all see how easy Tom makes the job of an architect? I don't have to ask him any questions. It's just great. There was one other aspect to this project that was interesting. In fact, this is the connection between the Stretto House and St. Ignatius, is the roof structure. As many of you know, the roof structure at the Stretto House is these voluptuous roof forms, curved forms, not just barrel vaults. They're actually segments of a sphere.
Yeah.
And how you structure that thinly and insulated was just brilliant. And you use the same system here. You want to talk about those 6-inch steel tubes, the round tubes?
Go ahead.
Well,
I want to see what you know.
I'll do it this way. When I came out to the job site one day, y'all know how framing often will go up real quickly. So I came out to the job site one day, and almost all this round steel tube framing was up. And walking up the driveway, seeing all this stuff on the Stretto House, honestly, it looked like an amusement park. It was just these white steel tubes. And God, it was just beautiful and brilliant. And I was just, the tubes have little tabs, and you could connect light gauge steel beams to it. And 2 layers of 3/8-inch plywood on the top and on the bottom, and then plaster and insulation in between. And just an incredibly thin structure. I talked to Tim Bade, who was Steven Holl's project architect on St. Ignatius, and he had the same exact experience with the roof here. He was just shocked at how thin it was. I see our time is up.
Ron, he's tough.
Yeah. So anyway, I think anybody going to Seattle, this is a site you need to go see. Thanks.
We accomplished the first handoff. So good evening. Excited to be up here visiting with you, Thomas.
Always exciting to be with you,
So,
Joanna.
Joanna Hampton, I have known Thomas probably 30 years. I had the opportunity to start my career with E.G. Hamilton, and the first project that we worked on was with Thomas, and that's how I got to learn a little about Thomas and how he helps us all as we try to solve some of our problems. Citizens Bank, an amazing project. I understand in talking to a few folks that it is very, very well known because when it was first opened, it was featured on the cover of Texas Architect magazine, and a number of folks have specifically mentioned that to me in thinking about this project. But I think this was the first of 4 precast projects that UNEG had started to develop, and as you were doing so, exploring how the precast could function, and I think you've got a detail in here where you guys started, which is pretty different from where you ended.
Well, this is a section through the spandrel beam, a horizontal spandrel beam, and E.G. called me, said he had this suburban office building to design, and so I went over to sit down with him, and he wanted these precast concrete elements, horizontal elements at each floor line, and then a concrete column at each corner. And the typical way that you would build that, and maybe even today, is this section that we're looking at. It's just by applying maybe a 4-inch or 5-inch thick precast concrete panel to be supported by the structure. It's just a facade element. And the problem with this system that I saw when I was sitting there talking to E.G., the problem with this system is you can only make those panels maybe 25, 30 feet long. And so every 25 or 30 feet, there'd be a joint. And I think this is sort of what the building would look like if we had proceeded with standard construction technology. You would have these joints in those beams, which to me, and by the way, on the American Embassy in Geneva, we had a similar problem on the 2 ends where the precaster wanted to break it into pieces, and I wanted it to be and E.G. wanted it. I mean, I wanted it for E.G., not. So I told E.G., I said, why don't we look at eliminating those joints and using 105-foot long precast concrete panels. Now, are actual structural beams, not just panels. And it's a 2-hour conversation to talk about the technical aspects. So I want to avoid that. But the main thing was the people. And I went to the contractor. I told EG, well, let me find out how much it'll cost. So I went to the precast manufacturer and I had some sketches and I showed them how I wanted to do the precast. And we had done this once before. We had slipform, concrete core, steel floor, and then precast around the perimeter. But that precast was very economical, and this was obviously going to be expensive. So at the end of the day, I knew after my research with the contractor that I could build this in the budget. So I went back to EG and I said that we can do this in the budget and let's proceed. And he liked that a lot, and so as you can see from these photographs that have been slides here, that these 105-foot long beams that we installed them, and then at the corners I had a detail where I post-tensioned them vertically, so that not only were they post-tensioned horizontally, but then the columns were post-tensioned, which clamped these beams very tight together where they couldn't deflect. And I was extremely concerned that I didn't want these beams to be sagging, and that would destroy the appearance. And the interesting part of the people story, which is not a great story, but the project manager was really, really upset with us that we were thinking about doing such a ridiculous thing as 105-foot long precast concrete beams on a building, and he was teaching project management at a university to a night school, and there were several of the students that called me that I knew they were contractors that were trying to become project managers, and told me that he spent 2 nights totally complaining about Thomas Taylor. And I don't think they learned that much. So we proceeded without, I never got into an argument with him, never got into a discussion with him, but EG gave the smile and the nod, and that was all I needed. And we built it this way, and as you mentioned, it was recognized by the Dallas chapter of the AIA as the 25-year award. It's just a little simple Richardson, Texas suburban office building, but it got the 25-year award because of primarily the structural system. So when it came time for the award, EG insisted that I join him at the AIA meeting. I said, EG, this is an architect award. This is an AIA award. He said, I know that, but I also know how much the structure contributed to the award, so you've got to be there, and I'm going to acknowledge your contribution, which he did as such a lovely, nice gesture on his part. And so this is us receiving the AIA 25-year award. So that's how a little simple suburban office building became the 25-year award winner in Dallas AIA. And I think the 25-year award win is the biggest award that the AIA gives. That shows the building had lasting architectural qualities. So that's how that story happened. And Joanna, I appreciate you so much.
Well, that is an excellent story. Thank you.
Hey, Thomas. I'm glad to be here. I'm Rob Barnes. Our company has been working with Thomas for 3 generations and well over 50 years now.
So our firm even longer than that.
Yes. So I don't know if you remember, but this will tie things together a little bit. On the old red courthouse, James Pratt was the architect, and we had a concrete structure in the beginning that we talked about changing to steel, and he was a little bit resistant in the beginning, but he was also one of the architects on the Brookhaven College project.
Yes, and you can see how much brick that this building had. This is a fairly old community college, but it's still in great shape, and it's a just all brick. And then not only brick on the outside, there's a tremendous amount of common areas on the inside, lobbies and other places that are face brick, not just plaster or something. So it's tremendous brick job. And on this slide, I had a concept that I thought was going to be very, very economical, and this is a plan view of the idea. It was what we call, quote, a cavity wall system. It had a face brick on the outside of the building and face brick on the inside of the building, and then it had this void of air space in the middle, which we call a cavity, and then I had these concrete pilasters that the contractor just poured during the construction of the precast, of the masonry. And then you can also see some little signs there as insulation. So these walls did everything. They supported 2 stories and actually 3 stories. It was the architectural expression of the outside of the building. It was the structure of the building. It was the insulation of the building. So all in one step, you had everything that you needed. But I was still worried that I was going to put something out on paper that would go out for bids, and that the bids would be too high, and so I would be responsible for blowing the budget on the project. And this is an example of what the cavity wall looks like when during construction. But so one morning, and I don't remember this story, but I'm pretty sure I remember this correctly. I was reading the newspaper and I saw that there was an article about the masonry union, and about some high percentage, I can't recall exactly, but maybe like 30%, some big number of masons were out of work. It was a bad time. So I called his grandfather, D. Brown, and asked him to come over to my office and look at my concept. There was that drawing that I just got through showing you. And he came over and he looked at it and he said, well, this seems to make some sense. I said, well, I need to be confident that before I draw this up and put it out on the market, I've got to be confident that this will work. So he said, I'm going to go talk to the measuring union. I'm going to go talk to my estimating staff, which was his father. And I'll get back to you and let you know if we can build this system in the budget. So several weeks went by, and do you have any stories about your father's cost estimating?
Not really, not too much. What I will tell you though, by designing a system this way, you eliminate the amount of trades on the job. And we were fully in control of the job site. Once the slab was there, it was 100% us until you got to the beam pockets that the trusses went into. We built a lot of those prefabricated, beam pockets off-site. We also probably employed somewhere, I guesstimated, my dad couldn't remember. He's, getting up there a little bit, but we figured it was probably somewhere between 80 and 100 people at the time.
Well, that was so exciting, from my perspective, having read this article in the newspaper about unemployment in the masonry industry, and then go out on that job site and see 80 to 100 masons just climbing all over this building that three months ago they were unemployed, couldn't feed their family. So that was, besides the fact that we brought the job in the budget and we accomplished the architect's preference, we also put 80 or 100 people that were out of work back working again. So it had rewards from every direction, beating the budget, bringing people to work, and that sort of thing. So really, your grandfather was one of the best, and loved working with him on so many fun projects. And
it's been really exciting for me as well, because a lot of the projects that were mentioned, I can remember working with your team on the Nasher project as well.
Yeah.
The economies of scale here is you just reduce the amount of trades. when we could put that amount of people on the project, we could really expedite the construction process.
So anyway, that's the story of the contribution that the people made, like your grandfather, to make this a success, and put people to work and bring the job in the budget, and it's a great masonry job, and thank your family so much for what y'all do.
Thank you.
So it's my privilege to get to talk about actually one of my favorite projects in Dallas-Fort Worth, the Irving Convention Center. And as you can see, as with all of Thomas's projects, an award-winning project. But this project almost didn't get built. I mean, if you aren't familiar with this building, you need to go drive by it and then go inside it. It is bold and daring and striking, and I think it's an architectural triumph. So again, it's one of my favorite buildings. But Thomas, tell us what happened and what you did to ensure that this project actually was built.
Well, this is a great people story. I don't know if Carl Williams is here tonight. He was the steel fabricator, but it would take a long time to tell any kind of a structural story about the design of this building. As anybody can see, that's an extremely complicated structure. But I got a call one day from the project manager on the project, and he said, we're down at Beck Construction Company, who was the project manager, and we've got everybody here from the executive director of the Irving Convention Center to the fabricator, the erector, the project manager, the contractor, architect, and we've got a big problem and we need you to come down. So I said, sure, and I jumped in the car and I was there in quick order and went into this conference room, and it was just, I don't know, 15, 20 people. It was packed with people, and they'd been discussing a scheduling problem all morning. And so after kind of hee-hawing around and not really getting to the point as to why they called me, I said, fine. I said, well, so what's the question? And they said, you know, we can't meet our schedule. We've got one tenant that's already signed up for the whole convention center, and that motivated the city council to move forward with building this convention center. Without that, there's a good chance that this project could go away. And so we realize that you're going to tell us you can't do this, but you've got to be finished with the drawings, and this was in early schematics. We hadn't done much. You had to be finished with the drawings in 3 months. And of course, everybody in the room that knew anything about construction knew that I couldn't design this building and draw this building and put it out for bids in 3 months. So I asked John Bosworth, who was the steel erector. I said, tell me how you plan to erect this building. He said, well, the way we've got it estimated now is that we're going to build it in 5 different sections. We're going to make 5 passes. We'll pass and build everything in this pass and come back and move over and do the next pass. So we got 5 passes, and each pass will take 7 weeks. And we've got to get started in 3 months or we can't meet the schedule. So I said, well, then what I want to do for you, this is John Bosworth, and he's retired now, but his firm is fabulous and they're still here. I said, well, John, I'll tell you, I want to give you pass number 1 in 3 months. Then I want to give you pass number 2 7 weeks later. Then I want to give you pass number 3 7 weeks later. And so in 5 7-week passes, we're going to finish this job, plus the 3 months. So I don't see what the problem is. And,
You knew how to sequence.
yeah. And he laughed and he said, I don't see any problem either, let's do it.
So the council voted to approve, correct? The council voted to move forward, correct?
They did, of course, we built it, and, it was that close. It was just, they were really, really afraid to go back to the city council and tell them that we're not gonna be able to make the schedule for this first, convention, and we're gonna have to cancel that. There were several other little quick things that I'll throw in, that I said, I can't do this project but one time. So we're gonna meet every week in my office, and we're gonna discuss each pass, and if you want bolted connections or welded connections or how, whatever you want, we're gonna decide right then, and then you'll never come back to me and say, hey, by the way, I want to change bolts to welding, because I can do what I told you I could do one time. And most of the time, we typically do all of our buildings 2 or 3 times, because we change our mind all the time.
No change orders on this one. So I mean, the architecture is front and center. What kind of challenges did you have getting it to be so bold and kind of in your face, if you will?
I'm sorry.
What part of the challenges you had in kind of getting the bones so obvious in the structure?
Well, it was those meetings, and the fact that the fabricator, the erector, they were all on board with coming up with great ideas, and how big a piece can we fabricate? WW Fabricators in Oklahoma, they had to ship all these pieces over land, and so how big a piece can you ship, and that sort of thing. So we solved all those kind of questions earlier, where so many times you don't solve those questions. Then all of a sudden you're trying to fabricate it or build it, and you can't ship it or whatever. Yeah. So that was the benefit of the weekly meetings.
So forcing rigor into the design process, but I mean, obviously an amazing accomplishment.
But I do appreciate getting all the credit, but on the other hand, you can see how important the whole team was.
Yeah, no, again, I encourage you, if you haven't seen this project up personal, go to Irving and enjoy it. It's I think a great addition to the fabric of Dallas-Fort Worth. So thank you, sir.
Thank you.
Maria?
Thank you. So Thomas, I started at GFF in 1999, and as I started to understand the lay of the land when it comes to design in Dallas, I started to notice that, and I think Ron mentioned it earlier, award-winning projects were always, very frequently, you were the structural engineer. And so I started to remember that and think, okay, when is going to be my opportunity to work with Thomas? And finally, maybe 10 years ago, we had the opportunity to collaborate. GFF is part of this very incredible project. I'm not going to talk too much about the project because I know Thomas has a lot of great stories to talk about. But as you can see in the imagery, these are renderings, obviously, because it's under construction. But the structural system is a very important part of the design. Primarily, and I wanted you to touch on a couple of things, and then we can talk about the people if we have time. But the columns are pretty unique. As you can all see, those columns are coming down, but they're not touching. They're kind of slipping. And so I just wanted you to kind of walk us through how much of a challenge that has been, and whether you would do it again.
Yeah, Nate, I don't know if we can back up and see a blow up of a V column. So that's well, go ahead. I'm sorry, go back the other way. And what Maria is talking about is these V columns. Typically, the two columns would equal the stress from one to the other, but in this project, the columns are offset. So there's a twist going on in the foundation because the two columns don't butt into each other. And I know that Kassan is here. I think I saw him come in, but there he is up there. He's magical, and his doctorate degree from the world's greatest university. And everybody, I'm sure, knows what that is. You know, very, 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 very complicated. Just simply because these two didn't touch each other, then it was twisting the foundation, and the foundations on piers and the pier cap, and so the engineering for doing that was pretty significant. And Ghassan did a fabulous job, and so that's the answer to that. But it took some major engineering analysis work to make that happen.
And I think we have some construction photos of that. But one of the things that I wanted to point out is that you don't know how to say no. When an architect says, I want to do this, you don't say no. You just go back and figure it out and find a way to push the envelope and really execute that designer's vision. So that's pretty spectacular.
I pretty much had to learn that from working with Max.
So we have a couple more photos that talk about the truss system of the floating bar and the support for the precast. So can you talk a little bit about that?
Yeah, that's an interesting thought, and as a matter of fact, we're planning to use that same idea on the DMA. It's really great to fabricate these steel trusses in the plant. The plant has cranes up above, it has trolleys up above, all kinds of ways to lift all this extremely heavy steel. But these trusses were 30 foot tall, approximately, and you can't ship a 30-foot wide truss on the highway. So this is a picture in the plant, and you can see they picked up one of the trusses and they're hanging it from the roof. And then the next slide, you can see on the left that this is still in the plant, but they put the truss all together where make sure that all the bolt holes and et cetera matched. And you can see there's a member that runs down the middle of these trusses. And so in reality, we fabricated these trusses as two trusses. And then that way we unbolted them, and we could, and then the biggest was 15 feet, and you could then ship a 15-foot truss from the plant to the job site. And so you see on the right, well, we stacked the two trusses on top of each other on the ground, and we made a 30-foot tall truss. And then we bolted it together at the mid height at the job site. So that added to some economy as well as speed of construction with that concept.
Great. I also wanted to talk a little bit about, you've talked to me in the past about how much you've enjoyed the collaboration with this team. Amy Hoffland, the director of the Crow Museum, and then obviously the Morphosis team with Tom Main and his team, which was the same team that was leading the Perot, which you were involved in as well. And so any particular stories that you want to share about that team?
Well, I shared Marie because there's a lot of them, but I forgot to think too much about that, except it was just a fabulous team. Morphosis did a great job. The direction from the Crow Museum was very consistent and direct. Beck did a wonderful construction job. It was just a overall good team of people from the owner's rep on down.
Do we still have time? Well, I just wanted to mention that the project is under construction, and I really hope that everybody has an opportunity to go see it. Even if you go see it under construction, it's pretty spectacular to see how it's coming out of the ground. And I also wanted to thank you, Thomas, for being such an inspiring figure in our design community. I'm looking forward to what it is that you're going to be working on next, because I'm sure it's going to be pretty amazing. And thank you for doing what you do.
Well, thank you for being here, Maria. I appreciate it very much. Thank you.
I'm Joe McCall. I worked with Bud Oglesby for 18 years, and then after Bud's death, I continued there at Oglesby for another 28 years, and formally retired a year or two ago. Ed?
Yeah, first I'll read it.
Turn it on.
You're on.
Hello?
Yeah, that's me green.
First, I'd like to say how much I appreciate Thomas. Over my career, I've had an opportunity to work with a lot of engineers. And at CERT's office, where I started working, we would work with Paul Weidlinger and William LeMessurier. And then when I started practice, we worked with a couple of professors at MIT, not nearly as successfully as the first two. But Thomas is the best I've ever worked with. And this project, which was the result of a competition, as you can see, has its whole character is based on its, frankly, structural improbability. And that long cantilever, which Thomas will talk about, 40 feet, makes a gateway between the Pioneer Cemetery, where the early leaders of Dallas are buried, and City Hall Plaza, particularly the flags of the city, the state, and the U.S. But right now, I want to hear Thomas tell how all these things work together.
Well, of course, you know most of the stories, but were you going to add to that?
No, other than, I think Ed referred to it as a Swiss watch, which it was, and this top piece not only cantilevered 40 feet, but it 10 feet in the other direction, and the whole thing was 90 feet long. And so, Thomas, talk about some of those challenges.
Yeah, if we go back to that slide, because that's the architectural expression of the project, and those stencils and those holes in the roof are the badge numbers of the fallen policemen that when the sun shines, you can see it silhouetted on the black asphalt pavement below. So Ed and John has some, this is not your routine structural, I don't know if you knew that or not, Ed, but so, I mean, the cantilever is 40 feet, and then the support is only on one side, so all the columns are on one side. So not only is it cantilever 40 feet, it's trying to twist. And then we had all those columns, and every one of them is leaning, as you can see, because of the twist between the elevation of the canopy and the base. And one of our meetings, first of all, I felt like that they ought to be stainless steel columns, and then architecture had it as stainless steel, but the construction cost estimate had it as steel pipes that were encased in a piece of stainless steel sheet metal, which left a joint down the face of the sheet metal. And these are not pipes. This is solid stock, 10-inch diameter, solid stock steel, because of all of the stresses that those columns had to support. A pipe with a hole in the middle of it wasn't strong enough. So I proposed at one of the meetings that we get, and by the way, all of this gets back to doing your homework and knowing what you can do and what you can't do. I called Houston and talked to some steel fabricators there, and all of that industrial petrochemical industry uses so much stainless steel. And they said, we can get you 10-inch diameter, solid stock, stainless steel that we use all the time. It's just a routine thing for us. So I didn't know exactly how much it was going to cost, but I knew it was available. So at the meeting when this conversation came up, and the contractor said, no, we're going to have to wrap it with sheet metal. And I said, well, I think there ought to be just solid stainless steel pipes. And the contractor said, well, where do you get something like that? And as you remember, I said, Home Depot. And we all got a kick out of that. And so I told him, no, you call these guys in Houston, they use it all the time. This is not unusual. And they did. How much was the total budget? $2 or $3 million?
Yeah, it was under two.
So right around $2 million project. And to do a stainless steel column instead of one that was encased in sheet metal was a $10,000 penalty, which wasn't much of a deal. The other issue is that beam that's on that side that's not only cantilevering 40 feet, it's also trying to rotate and twist because of the cantilever, because of the canopy. I put a steel tube there, a fabricated steel tube that was trapezoidal actually to meet the profile of the architecture. 4 steel plates welded together. And then in the middle, I put stiffener plates, and I drilled a hole in each of these stiffener plates. And I made the height of that hole get higher at the end and then lower to the middle, just like post-tension concrete. So I threaded rods through these holes, and so they went up, and I know everybody doesn't understand all this, and I'm not sure I understand either, but so it was all prepared to be post-tension because, and the post-tension would be at the far end, if you pulled on those tendons, it would raise the end of the cantilever up. Now you get all kinds of tolerances that I can't control. The mill has tolerances. They can. The fabricator has tolerances. The erector has tolerances, and our calculations aren't necessarily totally correct. And so you have to be prepared in something like this that's so important that somehow to be able to control the deflection, because you can't just do it with calculations. When we got through building the building, the end of the canopy was sagging 3/4 of an inch, which, by the way, your eye would not detect. But the fact that I had those tendons anyway, I went ahead and pulled that tendon, pulled the cantilever up till it was perfectly level. And you probably remember this at the police memorial dedication, the police chief said that the contractor had just measured the elevation of the top of the police memorial, and it was a 1/4 of an inch difference from the height of the level.
Yes, I remember that vividly. We were all there. Austin Commercial, who did a tremendous job on this. We were there the day that the construction was almost complete, and they had scaffolding at the very end of this to act as a theoretical column during the construction. And so it was, Thomas described these long cable, 90-foot long tendons, one on the top, one on the bottom, with these big nuts at the end. They had their wrenches out ready to do something if they needed. And then
hydraulic jacks.
Okay, yeah, that's a better way to put it. But so Austin disassembled the scaffolding slowly, and we all, in anticipation, were hoping it wouldn't turn into a potato chip or something. And so they took it off, and as Thomas mentioned, it was 3/4 of an inch or less, didn't even move. I mean, they had it torqued in a fairly neutral position, I suppose. You know more about that than me, but it was really wonderful that it was, this cantilever was dead level.
So one short comment about that. The committee, made up largely of policemen, were worried. They said, what happens if there's a crowd gets down there? Like, let's say the Cowboys win the Super Bowl and the place is overrun, they climb all over it. What's going to happen there? And Thomas said, I'll get back to you. And, he got back to him. He said, well, if you could put the starting line up on that cantilever, it may deflect almost a quarter of an inch.
So anyway, I know we've run out of time, Ron, but that was a very interesting project and a challenging project, and it's kind of dear to my heart, and I know it is to Ed and Joe, but at the dedication, I sat next to Officer Tippett, yeah, Officer Tippett. Officer Tippett was the policeman that was killed by Lee Harvey Oswald in Oak Cliff. And I don't know why I remember this, but he had an 8-year-old son when he was killed. Officer Tippett was killed. And at this dedication, I was sitting next to Officer Tippett's 8-year-old son, who was now a grown man, and sitting next to him was his 8-year-old son. So a lot of emotion that goes into this building, as well as some interesting structural challenges. And thank you guys both for this.
The next project, well, let me back up. This event was billed as celebrating Thomas's most significant structures. This is the antithesis of that. It's a kitchen remodel. We had a dining area. We didn't need a structural engineer, so we thought. But it was a very successful project otherwise, that for a client that we had done many projects for before. Contractor was excellent. John Hardy, Steven's dad. Steven's here tonight, and Steven has, we all know well that craftsmanship. But I designed this dining table with I was all proud of it, with the fancy base, stone top, Polson pendant light above it. And so after completion, we got a call about a week later from the client. He said, Joe, everything's wonderful except one thing. It is absolutely a problem, and it's got to be fixed, and we're not going to pay your bill until you fix it. So we went over there and looked at it, and what happened is the table would vibrate and shimmer. It was out of control. I mean, you felt like there was an earthquake tremor going on with your wine glass, your water glass, and everything was wobbling. And so I went over and looked at it and quickly realized that I was out of my element. And so I used my nickel, I called Thomas, and I told him the problem. He said, Joe, can we go over and look at it? I said, sure. So on a Saturday morning, we went over, the two of us. Thomas got down on his hands and knees. He crawled all over this thing. He shook it. He messed with it. He asked me questions. He took photographs, and then he said, Joe, let me take it back to the office and look at it. So he did. He put it in all these sophisticated computer programs and analyzed my table. And it was a little taller. It was a 36-inch, so it had a little longer. So we used bar chairs. But so anyway, 2 days later, Thomas called me back, said, Joe, I think I've got a solution. He sent it to me. I took it. We went over with a fellow in our office with a pickup truck. We disassembled it, put it in the back of the pickup, took it over to the welder that fabricated it in the first place. They followed Thomas's instructions, did some select welds, and then we took it back, reassembled it, and it was perfect. It was just perfect. Didn't wobble at all. Thomas never sent us a bill, and so really, I'd revered Thomas prior to this, but it really spoke to me about the essence of Thomas, his curiosity, his genuine curiosity of all this, his skill, his expertise, and really more than anything, just his love of his craft. I mean, that exemplified it so well. And Thomas just now remembered this whole project. Reminded me that he didn't get paid for it.
Well, it was that nickel, I think, that was my fee. You put in the phone, put in the telephone. Maybe because I don't know how far behind we are, but I wanted to close by a story about Bud Oglesby, who I couldn't have loved more. He was probably one of my very first clients when I was first started, and I was 25 or 26. And he trusted me for all those years. And he called me after 40 years of working together, or 35 or whatever it was. And he said he had he wanted to build a house for his wife, Peggy. And if I could come over, so I went over to his office. He said, no, come to my house. So I went to his house, and he came to the door, had this terrible, terrible frown over his face, pretty tattered robe. Both of his pockets were full of pills, and he was taking these pills and looked so sick, and I didn't know what was going on. We went to the dining room table, and he told me the story about how much he loved his sons and how successful they had been and how great they were and what they were doing. And so we went through that story, and all that time he was taking pills and always frowning. And then he finally showed me the house as to what he wanted to build for her, and that there's this special room that had a beautiful view out onto the creek, and he wanted a special roof in that space that kind of celebrated that view out to the back. So I said, okay, well, let me go back to the office and study this, and I'll call you. I called maybe Joe, or I don't know who I called at Oglesby, and I found out that Bud was at the end of his time, and he wanted to build his house. He had terrible cancer and wanted to build his house for his wife, Peggy. And so it was kind of urgent, and also that's why he looked so frowned and stuff. So I studied and I studied and I studied, and I came up with a neat little concept that I thought would work. And I built a little model. It's sort of those little models that you could kind of look inside and you could see the glass on the outside, and then you could also see the roof and the glass and the space. So I built this little crude model, and I called Bud and said, well, I had an idea. It's just idea number one, and if you don't like it, we'll go to 2, 3, 4 until we find what you want. So I went back to Bud's house, and he answered the door, and he had this big frown on his face. He had this tattered robe and these pills in his pocket, and we sat down at the dining room table and told me how much he loved his sons and how great they had been doing, and what wonderful, and by the way, they are, and what wonderful kids they were, and how proud he was of them. And so we went through that conversation and finally got to the house. I said, well, Bud, I built this little model of an idea. It's up to you. It's your reaction. You tell me if you like it. You tell me if you want to modify it. You tell me how you feel about it. So I handed him my little model, and he took my little model and he looked up into the air, looking like this, into the model, and a big, big grin came across his face. He said, I knew you could do it. So
Thomas, in the last days or the last year, Bud worked closely with Thomas and a young intern in our office named Cliff Welch. They collaborated and put this thing together, realizing that Bud's days were numbered. And in that previous photo, Peggy, after Bud died, built the house about 3 or 4 years later. Don Romer did a wonderful job. Don's here today. There's Don. And in the photo is Peggy. Peggy and Richard still live there today.
Well, I did want to say one thing about what Don, it is about the people, and what he contributed was probably more than what I contributed. But if you go back to that slide, this one right here, it's too small, you can't see it too well. But Don came to my office one day. He had just started construction. And so he came in, and I said, well, come on in, and I didn't know exactly why he was coming, but he said, I've been looking at your connections of the cables and all, which were these old kind of farmhand looking kind of cables that you might see on at a barn somewhere or something that's traditionally used in the steel industry. He said, I wanted to show you these connectors. And he pulled out these absolutely beautiful stainless steel connections. He said, I wanted to see if this would be something you'd be interested in. And Don, that's the most beautiful thing I have ever seen. And yes, absolutely, let's do that. So he totally transformed a crude truss system into a beautiful truss system with these stainless steel connectors that just made it all worthwhile. So it's not just, it's just not you and me, it's the contractor and people like that that make these successes. But anyway, that's a story that I'll never forget, Don, and I appreciate so much what you did to contribute to this building.
That actually reminded me yesterday, back in the day, that about Bud and Thomas, back in the day, Thomas drove a Alfa Romeo convertible, and Bud drove a Porsche convertible, and they were quite the suave dudes in the day.
I don't think that we need to talk about that. And then also that one slide, I think we can pass. I think we've kind of taken all of our time, but this was another project I did for Bud. This is the Carrollton City Hall, and he called me over and he said he wanted to make a city hall an octagonal. He wanted the roof to slope, and he wanted a skylight at the center of the roof, and he wants to expose the steel. So that's your job. And so what you see there is actually, I don't have a picture of the model, but I built a little model, and all those are steel tubes, 4x4 steel tubes that are going up to this and intersecting at the center. That's actually support the skylight and the roof, and that's all exposed. And Bud loved it, and there it stands. Nate, thank you so much for the opportunity to be here tonight.
So when I first started with the forum about 20 years ago, I heard about kind of legends in the area, and it was several years after hearing about you, Thomas, and the legend that you were, that I was finally able to meet you in Dane. And I mean, I think because everyone here and the people that are shared tonight, all of us appreciate you because number one, you're a gentleman, you're an incredible structural engineer, but most of all because you care about people. And we love you and Dane very much, and I want to thank you for everything.
Well, thank you.